Welcome to Study Loop.
In this problem, we are provided with the initial value problem y double prime minus 6 times y prime plus 9 times y equals to 9 times t plus 3 minus of 18 times t times e raised to the power 3t plus 4 times e raised to the power 3t. And further, we are given that y of 0 equals to negative 2 and y prime of 0 equals to negative 10. So first, let us write down the characteristic equation. We have r squared minus 6 times r plus 9 equals to 0. So factorizing this, we have r minus 3 the whole squared equals to 0, which implies that r equals to 3 and 3. Since we have real equal roots, the solution is given by c1 times e raised to the power 3t plus c2 times t times e raised to the power 3t. So let us mark this as equation number 1. So next, we need to find out the particular solution. We use the method of undetermined coefficients. So the particular solution of negative 18t minus 4 the whole multiplied with e raised to the power 3t is of the form yp equals to t square times at plus b times e raised to the power 3 times t. So now let us differentiate this. So differentiating it for the first time, we obtain 3 times at cubed plus 3 times b plus 3a the whole multiplied with t squared plus 2 times, only these two terms are multiplied with t squared plus 2 times b times t, and this whole thing is multiplied with e raised to the power 3t. So now differentiating this for the second time, we obtain 19a times t cubed plus 9b plus 18a the whole multiplied with t squared plus 12 times b plus 6 times a the whole multiplied with t plus 2b, and all of these terms are multiplied with e raised to the power 3t. So now substituting this in the given differential equation and simplifying, we obtain 6at times e raised to the power 3t plus 2b times e raised to the power 3t equals to negative 18t minus 4 the whole multiplied with e raised to the power 3t. So equating the coefficients on both sides, we have a to be equal to negative 3 and the value of b is negative 2. So we have yp1 to be equal to negative 3t minus 2 times t squared times e raised to the power 3t. Mark this as equation number 2. So next, the particular solution of 9t plus 3 is of the form yp2 equals to at plus b. So differentiating this for the first time, we obtain a, and differentiating it for the second time, we obtain 0. So substituting this in the given differential equation, we have 9at plus 9b minus 6a equals to 90 plus 3. So equating the coefficients on both sides, a equals to 1 and b also equals to 1. So substituting that, we get yp2 to be equal to t plus 1. Mark this as equation number 3. So adding up equations 1, 2 and 3, we obtain the general solution y to be equal to negative 3t cubed times e raised to the power 3t minus 2t squared times e raised to the power 3t plus t plus 1 plus c1 times e raised to the power 3t plus c2 times t times e raised to the power 3t. So now we make use of the initial conditions. So making use of the initial condition that y of 0 equals to negative 2 and y prime of 0 equals to negative 10, we obtain the value of C1 to be equal to negative 3 and we obtain the value of C2 to be equal to negative 2. So substituting this, we have the solution to be y equals to negative 3t cubed times e raised to the power 3t minus 2t squared times e raised to the power 3t plus t plus 1 plus c1, which is negative 3 times e raised to the power 3t minus 2 times t times e raised to the power 3t. And therefore, this is the required solution for the given initial value problem. This is our final answer.